7.5 Refractions and the line symmetry. A line of symmetry is called a line of refraction. Let's look at the example here. I have A, B, C, G, which is a quadrilateral. And this one was A, E, D, G, another quadrilateral. They are symmetrical. So the middle line is called the line of symmetry. And you can find that two shapes on both sides of the line of symmetry must be even. The line of symmetry looks like a mirror. Mirror the original shape to its refraction image. So if I take this one as the original shape, the other side, refracted by the line of symmetry, is called the refraction image. This line of symmetry looks like a mirror. If a mirror is placed along one side of a shape, the refraction image and the original shape together form a larger shape. So the larger shape for both of these two quadrilaterals is a regular pentagon. In this regular pentagon, you can find each point on one side of the line of symmetry has a corresponding point on the other side of the line. For example, point B is one point in the original shape. This point has its corresponding point on the other side of the line of symmetry. Its corresponding point is E. These two points are the same distance or equidistant from the line of symmetry. This one means if I draw a perpendicular line from B to the line of symmetry, this one represents the distance from B to the line of symmetry. This BF is equal to the same distance from E to the line of symmetry, which is EF. And BE, this entire one, must be perpendicular to the line of symmetry as well. So this is a very important property of line of symmetry. We can find another pair of corresponding points in both of the original shape and the refraction image. So the other pair is C and D. Both of them are equidistant to the line of symmetry. Point A is on the line of symmetry, so the distance from A to the line of symmetry is 0. So on the refraction image, the distance from this A to the line of symmetry is also 0. Example 1. Identify the lines of symmetry in each tessellation. Let's look at the first tessellation. Most of you guys can discover the line of symmetry very quickly. So the line of symmetry should be the middle one. So you will see the left side is the refraction image of the right side. Or you can see the right side is the refraction image of the left side. So there's one line of symmetry in this tessellation. Let's look at the tessellation, which is a square shape with 16 little squares inside. We can tell there must be one vertical line of symmetry. If you fold the shape along the line of symmetry, the left side can overlap the right side. So this one is the line of symmetry. We also can find one horizontal line of symmetry because if you fold the shape along this pink line, the top side will overlap the bottom shape. We also can find this diagonal is also a line of symmetry because this triangle is the refraction image of this upright triangle. We also can see the other diagonal is also the line of symmetry because this part is the refraction image of this right triangle. Let's look at example 2, identifying shapes related by a line of refraction. Identify the triangles that are related to the shaded triangle by a line of refraction. Describe the position of each line of symmetry. So the shaded triangle is the red one. Let's look at the relationship between this shaded triangle and the triangle A. We can tell that triangle A is a refraction image of the shaded triangle in this line. So let's say in the blue line. So I will use the blue color to show the blue line. Since this blue line is a vertical line, it passes through the x-axis. So let's read a number for this blue line on the x-axis. So this one is 1, 2, 3, 4. This is 5. So the blue line passes through 5 on the x-axis. Let's look at the relationship between the shaded triangle and the triangle B. We can tell triangle B is a refraction image of the shaded triangle as well. Let's use a red line to show the line of refraction. So this line of refraction is a horizontal one. And right now, I use the red color. So I will say triangle B is a refraction image of the shaded triangle in the red line through, I still can read a value on the y-axis to represent this line. So this line is 3. So pass through 3 on the y-axis. Let's look at the relationship between this shaded triangle and the triangle C. We can tell that triangle C is not a refraction image of the shaded triangle. Let's look at triangle D. We find triangle D and the shaded triangle. They are symmetrical. They are symmetrical about this line. It's an oblique line. So I use the green line to show the line of refraction. So triangle D is the refraction image of the shaded triangle in the green line through points 9, 1. Here is 9, 1. And 1, 9. This is 1, 9. So this triangle D is a refraction image of the shaded one through this line. Let's look at example 3, completing the shape given its line of symmetry. Quadrilateral ABCD is a part of a larger shape. Draw the image of ABCD for the given line of symmetry, which also can be called the line of refraction. Write the coordinates of the larger shape formed by ABCD and its image. Describe the larger shape and its symmetry. The first one is a refraction in the horizontal line through 2 on the y-axis. Let's draw the line of refraction first. This refraction line is a horizontal line through 2 on the y-axis. So I will find a point 2 on the y-axis and draw a horizontal line. We can see that point A is on the line of symmetry. So point A should be a common point for both of the original image and the refraction image. So point A has the coordinates 2, 2. The point of its image is still A, 2, 2. Let's look at point B in the original shape. Point B has the coordinates 4, 4. We need to find its corresponding point in the refraction image. The corresponding point of B in the refraction image should be on the other side of the line of symmetry. And this point B with its corresponding point B prime should be equal distant to the line of symmetry. B to the line of symmetry is 2 units away. So I need to find 2 units away on the other side of the line of symmetry. So I can find B prime here. This one is also 2 units away from the line of symmetry. So the coordinates of B prime is 4, 0. Let's look at point C. The coordinates of point C in the original shape is 6, 4. We can use the same way to find its corresponding point on the other side of the line of symmetry. Since C is 2 units away from the line of symmetry, so on the other side, C prime should be also 2 units away from the line of symmetry. So C prime has the coordinates 6, 0. The last point is D. D, we can read the coordinates from the graph. It's 6, 2. Since this D is on the line of symmetry, so D prime should be the same as 6, 2. Then we join the points up to form the refraction image. So the purple one is the refraction image. So the larger shape is a pentagon with line symmetry. And the line symmetry is the horizontal line through 2 on the y-axis. Let's look at B. A refraction in the vertical line through 6 on the x-axis. Let's draw this vertical line, which is the line of symmetry first. So this line passes through 6 on the x-axis. So 6 is here. So the vertical line will be this one. So let's read the coordinates of every single point in the original shape first. So point A has the coordinates 2, 2. Point B has the coordinates 4, 4. Point C has the coordinates 6, 4. Point D has the coordinates 6, 2. Let's find its refraction image, as well as the coordinates of each point on the refraction image. Point A is 4 units away from the line of symmetry. So A prime is also 4 units away from the line of symmetry on the other side. So I will find on the right side, I go by 4 units. So A prime is here. If we read the coordinates for point A, it's 7, 8, 9, 10. So it will be 10, 2 for A prime. Let's look for B. B is 2 units away from the line of symmetry. So on the other side, I will find 2 units away as well. So this is the corresponding point of B. B prime has the coordinates 8, 4. Point C is on the line of symmetry, so C prime overlap with point C. C prime is also 6, 4. Point D is on the line of symmetry, so D prime overlap with point D. So D prime also has the coordinates 6, 2. Let's join the points up to form the refraction image. So if we look at the larger shape, so the larger shape is an isosceles trapezoid. The line of symmetry is the vertical line through 6 on the x-axis. Let's look at C, a refraction in an oblique line through 0, 0 and 6, 6. So let's draw the oblique line, which is the line of refraction first. This line passes through 0, 0 and 6, 6. Let's find these 2 points based on the coordinates first and plot those points on the coordinate system. So then I can join these 2 points up. So this green line is the oblique line of symmetry. Let's read the coordinates of each single point in the original shape first. Point A has the coordinates 2, 2. Point B has the coordinates 4, 4. Point C has the coordinates 6, 4. Point D has the coordinates. Let's draw its refraction image in this green line. Since point A is on the line of symmetry, so its corresponding point is still on the line of symmetry. So A prime has the coordinates 2, 2. Let's find B prime. Since B is on the line of symmetry, therefore B prime is also on the line of symmetry. So B prime has the coordinates 4, 4 as well. Point C. Let's find its corresponding point on the other side of the line of symmetry. Point C has this much distance to the line of symmetry. I will use the same way to draw the distance on the other side of the line of symmetry. Then I can tell this is C prime. Read C prime from the coordinate system. So C prime has the coordinates 4, 6. I will use the same way to find D prime, which is the refraction image of point D. D, I will draw a perpendicular line to the line of symmetry. This one is the diagonal of 2 by 2 square. So on the other side of the line of symmetry, I will draw the diagonal of a 2 by 2 square symmetrically. So this point should be D prime. Let's read the coordinates for D prime. D prime is 2, 6. So right now, let's join the points A prime, B prime, C prime, D prime together. So we can find the purple one with the original image. This one is one L shape. So we call this shape a concave hexagon with line symmetry. The line of symmetry is the oblique line through points 0, 0 and 6, 6.